Okay, guys, so we're going to look at our last type of factoring that we're going to deal with this year, and it is factoring by a difference of perfect squares. And you guys have actually looked at one of these before. It was on an assignment from last week, and we're just going to kind of go through it a little differently. There's a little shortcut that we can take. So before we get started with anything, this word right here pops out to me, and it's that word difference. For us in math, that's talking about subtraction. Okay, so in these factoring problems, it's going to have subtraction in it. The other part of this, perfect squares, we're going to talk about that now. Okay, what is a perfect square? So a perfect square happens when it has factors that are the same. Okay, so what we mean by that is if we have something like, I'll pick one actually that's not on here, we'll say 144. 144 is a perfect square because it's factored, or it could be factored into 12 times 12, okay, where it has a square root is what you might hear that as said, a square root of 12, or that it has factors that would be the same. So what I did is I just made up a quick little chart here with the first 10 perfect squares. Okay, so when we're dealing with these, I wrote those all as exponents. Okay, but this would be like 1 squared is the same thing as 1 times 1. Okay, so 1 times 1 would give us 1. So 1 is a perfect square. 2 squared, or if you wanted to think of it as 2 times 2, well, 2 times 2 will give us 4. So 4 is a perfect square. 3 squared, which is the same as 3 times 3, if you wanted to think of it that way. 3 times 3 gives us 9. Okay, and so on. 4 squared, or 4 times 4 is 16. 5 squared would give us 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. And 10 squared is 100. Now, perfect squares, they go on forever. We could keep doing 11 times 11, 12 times 12, 13 times 13, and coming up with a whole big list. I just did the first 10. Those are the ones that you should be the most familiar with and the most that you'd see in these. Everything else that's a little bigger, you could always check it in your calculator to see if it's a perfect square or not. Okay, so before we even get into factoring, we're going to look at this review here with some multiplication. So they're asking us to multiply x plus 9 times x minus 9. So I see here I've got a binomial, x plus 9, and another binomial, x minus 9. So I'm going to multiply those two things together. I'm going to draw myself a box just to help keep myself organized. And since I'm multiplying, I'm going to put my factors, the things I'm multiplying, on the outside of the box. So, and then I'm going to go ahead. If I want to fill these in, this is like x to the first and x to the first, just so I remember what to do with those, I can go ahead and multiply these together. X to the first times x to the first gives me x to the second power. X to the first times negative 9 gives me negative 9x. Positive 9 times x to the first gives me a positive 9x. And positive 9 times negative 9 gives me negative 81. Okay, so what's happening here is when I look at these, the next step is I don't leave it in a box, but I've got to take the answers out. So what I would take out is the polynomial and then combine my like terms. So I have an x squared. There's no other x squared, so that's going to come with me. I've got a positive 9x plus a negative 9x. So positive 9 plus negative 9, that's going to equal 0. So we're not even going to write that. I mean, I can write it down for now, but usually that's not written in. And lastly, I have this negative 81. Or minus 81 in this case. So it looks kind of funny like that. And usually this isn't the way that they're going to leave it. This 0x kind of looks funny in the middle. So what happens is it just gets written as x squared minus 81. So that's what happens when we multiply these. So what we can kind of see that happens is now we're left with a difference of squares. I have my subtraction, so I know it's a difference. X squared, I can factor into x times x, which means that that's a perfect square. 81 can factor into 9 times 9, so it's a perfect square. And if I look back at the problem that we had at the beginning, I can see that both my parentheses started with an x, both my parentheses ended with a 9, and then inside there was 1 plus and 1 minus, which is what got that middle term to cancel out. So when we're talking about factoring and multiplying, they're opposites of each other. So we can use this form to help us out. So I'm going to just jot something down here on this page, and then we'll do 4 examples, and I think you guys will get it. So anything that's in the form a squared minus b squared, where a squared and b squared are both perfect squares, it can be factored into this form of a plus b times a minus b. Okay, and that's really our difference of squares here. And you'll hear it sometimes say difference of 2 squares, difference of perfect squares, difference of squares. They all mean the same thing. People call them a little different each time. So if you look at YouTube videos or Khan Academy videos, they might call it a little different depending on the person. So here's our 4 examples. And then you guys will do a little practice. So the first 2, it's a factor the following. So we've got this first one. We want to factor x squared minus 4. So the first thing I notice, in order to use difference of squares, it's got to be a binomial, so it only has to have 2 terms, and in between it has to be a subtraction sign. If it's addition, I can't even use this one. It won't work. So then I've got to think about this. X squared. Well, that's a perfect square because that would be x times x. Well, 4 is a perfect square too. 2 times 2 would give me 4. And if it's helpful to write this down, you can. So I can factor this using that form we just talked about. So it's going to go into 2 sets of parentheses. In the front would be x times x would give me x squared. 2 times 2 gives me 4. And then I need 1 parenthesis with a plus, 1 parenthesis with a minus. If you write it backwards, that's okay. If you wrote it this way, with the x minus 2 first, these 2 mean exactly the same thing, as long as 1 parenthesis has a plus and a minus, and the other a minus in between those 2 terms. So here at the second one, now we've got x squared minus 49. So x squared, we just said that one. X squared has to factor into x times x. 49 is a perfect square. Well, what times itself would give you 49? And that's 7 times 7. So because we have this subtraction here in between, I know I can factor difference of perfect squares since it is a difference, and they are both perfect squares. And then I just fill in the rest of my parentheses. One of them needs a plus 7, the other a minus 7. Okay, and then these last 2. Okay, so same directions, factor the following. So we've got 100 minus x squared. Okay, so I see it's subtraction, so I know I've got my difference. 100 is a perfect square because 100 could be written as 10 times 10. X squared is a perfect square because I can do x times x, so this is going to work. What I've got to just pay attention to here is make sure that I put things in the correct order. So the first thing when I set up my 2 parentheses is this 100 is first. The square root of 100 we said was 10, so that needs to go first in my parentheses. Second was the x squared, so that's going to be the second part of my parentheses this time, 1 with a plus and 1 with a minus, and then it's all factored. Last but not least, number 4 down here, we've got 36x squared minus 25. So check it. First thing we notice, there's a minus sign in between our two terms. Okay, so that is a difference. 36x squared, that is a perfect square. I can look at my 36. Well, that could be 6 times 6. We have the x squared. We've done that one a bunch. It's x and x. So 6x is going to be the first part of my parentheses. 25 is 5 times 5. Okay, so both are perfect squares, so this is going to work. So second part of my parenthesis, that's going to be my 5s, one with a plus, one with a minus. Okay, and then you guys are going to practice this a little bit this week. So I hope that this made sense to you. If you have questions, as always, please reach out and contact one of us. Okay, thank you.